June is National Ocean Month in the United States, and earlier this month, the whole world observed World Oceans Day, a day that has been celebrated since 2008 with a different theme each year. The theme for 2021 was Life and Livelihoods. Covering 71% of the Earth's surface, the ocean is home to a vast array of life, an estimated 2.2 million species, and provides livelihoods for 40 million people in the fishing industry. But many scientists warn that the health of our oceans is in decline, threatening these species and the humans who depend on them. This is Julia Baker with the Oxford Comment. The threats to our ocean's health are multifold and include deep-sea mining, offshore drilling, and ocean acidification. On today's episode, we'll be talking to two academics whose specialties cover three further threats: overfishing, climate change, and biodiversity loss. For our first interview, we were excited to welcome Lisa Levin, a biological oceanographer at the Scripps Institution of Oceanography at the University of California. She is a leading expert on the effects of climate change on deep-sea biodiversity and co-authored the climate change chapter of our book, Natural Capital and Exploitation of the Deep Ocean. Lisa talked to our science correspondent, Victoria Sparkman, about climate change and its impact on biodiversity in the deep ocean.
Hi, Lisa. Thank you so much for joining us on the Oxford Comment podcast today. We're happy to have you here. Can you please just introduce yourself to our listeners to start off and tell us a little bit more about your contribution to the OUP book, Natural Capital and Exploitation of the Deep Ocean?
Sure. I'm a biological oceanographer at Scripps Institution of Oceanography at UC San Diego. I study animal life on the seafloor in both coastal and deep sea ecosystems. And my deep sea science focuses on ecosystems on continental margins and their vulnerability to climate change. My contribution to the book that we're speaking about was the chapter on climate change in the deep sea, which I co-authored with Nadine Labrie. She was the lead author. More generally, this book brings together internationally recognized scientists, economists, and legal experts to describe the processes by which humans can benefit from natural capital of the deep sea in a sustainable framework. And this concept is really the idea that, or the concept underlying this book is the idea that sustainability requires communication among all deep sea stakeholders. So one goal of the overall volume is to facilitate future discussions between the many different sectors of society that will influence the deep ocean for generations to come. And I believe that climate change has to be part of this discussion if we want to consider the future of the ocean.
Thank you. So before we kind of get into climate change's impact, can you explain a little bit about why deep ocean biodiversity is important?
Yes, there are many reasons. I think they're mostly out of mind for the majority of people on the planet, but I like to start with climate. The deep sea, which is all the waters we consider below 200 meters or about 600 feet, is a really critical part of the carbon cycle that removes carbon dioxide from the atmosphere. Biodiversity in deep waters contributes to the uptake of that carbon out of the atmosphere and down into deep water, and to the transport of that carbon. And then once the carbon reaches the deep sea, animals on the bottom bury that photosynthetically produced carbon. Some also filter out methane that's coming from inside the earth, coming out towards the atmosphere, and they are able to fix that methane and keep it in the ocean, sequestering it essentially. Mm-hmm. So all of this is important to people because it helps regulate the temperature on this planet, on Earth. The deep sea also recycles nutrients. We call that remineralization, and it basically contributes to the massive productivity of the ocean. The deep sea provides humans with a variety of other services that we call provisioning services, in that they have a market value, and this would include food, fish and shellfish, the potential for pharmaceuticals, new kinds of biomaterials and industrial agents, And a lot of what we consider to be genetic potential, the potential to adapt to a changing ocean and to adapt to climate change. There are other kinds of services, some we call supporting services. They provide the habitat that is critical to our fisheries, for example, nursery grounds and feeding grounds and breeding grounds. There are cultural services provided by the deep sea. We tend not to consider them as too much, but they are certainly significant for some cultures. Traditional knowledge and belief systems consider the people on this planet to be stewards of the deep sea, and they have origin myths and a lot of value and respect for the deep ocean. But the deep sea has also been inspiration for art and literature and movies. It's important space for our communication cables. Unfortunately, it's become space for our contaminants and debris and waste that we dump. Has important education, scientific research. These are all different kinds of cultural services that the deep sea provides.
Wow, thank you so much for explaining that all to us. That's very interesting. So how would you say then that climate change impacts the deep ocean biodiversity?
It's very much the same as shallow water, but we know less. We know that warming oceans will cause species to move, to seek cooler waters, to become warming oceans raises metabolic rates. So species in the deep sea, which are already often food deprived, can become even hungrier. If they can't move away and conditions get too warm, they could die. Oxygen loss is a consequence of ocean warming. Basically, warmer waters hold less oxygen, less gas solubility, and they're more stratified, so there's less mixing. So oxygen has essentially a very similar effect to warming. It causes species to migrate away, and if they can't migrate, they might die. We know less about the effects of ocean acidification. That's another climate change impact in the deep sea. That is basically a lowering of the pH of the waters, and it makes it harder for calcifying animals like corals or bivalves, shelled animals, to produce their shells. But we also know that lower pH will dissolve the non-living parts of cold water coral reefs. Much of the reefs that provide habitat and support biodiversity is actually rubble, or the non-living part, and it can begin to dissolve as the waters become more acidic. There are other kinds of climate change effects. We know that food supply for the deep sea is likely to be reduced over vast areas simply because surface production, phytoplankton production, is going down. There are changes in circulation happening. We're not so sure it'll affect the connection between different populations, but we're not so sure about the consequences. And all of these changes aren't happening in isolation. They actually co-occur, and together they probably can reduce the resilience of deep sea populations, making it harder for deep sea communities to recover from other forms of disturbance that they might experience.
Gotcha. So I imagine some of those impacts are very visible to see, like you mentioned, migration patterns and things like that. Are there any other ways that you would prove that climate change impacts deep oceans?
Well, honestly, the best proof for climate change impact in the deep sea comes from the paleo record, from sediment cores and fossils of animals that existed long ago. We know from these records that when we have warming oceans and reduced oxygen and ocean acidification, that we begin to see biodiversity loss and sometimes mass extinctions. But in the modern, it's much harder to document, especially in very deep water. Long-term observing and monitoring can be a start, but even decades of records look like they aren't enough to actually confirm climate change impacts relative to natural variability and, say, interannual or decadal cycles of variation. But we need to do more observing and monitoring. I think we can also use models and improve our models of what to expect in the way of change. We have a variety of climate models, but also habitat suitability and connectivity models that can help us make predictions about which systems are going to be vulnerable or which species will be vulnerable. Of course, these need to be ground truth. And then there's a few species that we can raise in the laboratory, and we can begin to do experiments to understand their response to climate change.
Gotcha. Are there any other factors that would contribute to a loss of deep ocean biodiversity that haven't been mentioned? And maybe how can we reduce our contribution to these factors?
Well, there are other factors that will affect biodiversity. Overfishing is one of them, but there are others. The potential for, as we spend more and more time in the deep sea, we may move species around, invasive species, or introduce disease. Contaminants we know are making their way into the deep sea, but we don't know that much about the consequences. They can't be good. Things like oil spills, changes in substrate that result from either resource extraction activities or and physical disruption of substrates is probably going to affect deep sea communities. There are consequences of activities that are being considered but haven't begun, like deep seabed mining, the release of sediment plumes and contaminants from mining, light and noise. All of these can also contribute potentially to loss of biodiversity, but they haven't been well studied, and it's very hard to study these. So how can you asked a second question about how we can reduce our contribution to these factors. I mean, there are many levels to answer this, right? We can have, sort of at the policy and regulation level, I think scientists need to engage industry in discussions about best practices aimed at sustainability. We need to also think seriously and have a very informed debate about areas where industry is considering expanding into the deep ocean, where there are new industries being considered or new types of development being considered. We need to think about whether these are sustainable and compatible with future needs. There are all sorts of conservation measures that can be considered at this point in time. Marine protected areas in the deep sea. There are different types of fishing practices. And of course, reducing climate change in general is going to be helpful to solving climate change problems in the deep sea. We can think about ways to control our waste and debris, plastic especially, but all the contaminants. At the international policy level, there's a new treaty being negotiated on biodiversity beyond national jurisdiction, and this can go a long ways, if done right, towards helping, but that needs state engagement, and we need the different UN agencies and bodies to come together to work together to fill governance gaps. So that's sort of the high level answer, but what we can do at the individual level, there's a lot. Each person can think about what kinds of vehicles we drive, where we get our energy, what kinds of food we eat. For the deep sea, we can really consider avoiding eating deep sea fishes that live hundreds of years, for example.
Yeah.
And many do. We can reduce our metal demands by recycling and using our products longer and having better disposal practices that might actually reduce the demand for mining metals out of the deep sea, for example.
Wonderful. Thank you very much. It's a lot of good advice there. So, Lisa, are there any potential consequences for humans due to this lack of deep ocean biodiversity that you can see in either the short or long term?
Yeah, well, I would say the lack of biodiversity is something that we want to avoid.
Mhm.
I wouldn't say it's something we have now. Right now, the deep oceans are very biodiverse,
Mhm.
and there is interest in keeping them that way. And the consequences, some of them we can speculate about, and some of them we probably don't know yet. You know, the deep ocean is critical to productivity of the ocean and carbon uptake, as I've talked about. I think we are beginning to recognize that there's an amazing array of natural products down there that are going to be cures for diseases,
Mhm.
some of which are in trials, but probably most of which we haven't actually discovered yet. I think the deep sea, the genetic diversity in the deep sea probably is going to provide solutions to the problems that either problems we don't have yet and will have in the future, or problems that we have that we don't even know about yet. There are certainly some of those. I think also loss of deep sea biodiversity would indicate our failure to fulfill our obligations as stewards of life on this planet. I
Mm.
think really humans have a responsibility to help conserve life rather than make it go extinct. And many traditional cultures recognize this need, and I think others are beginning to as well. But I think it's worth pointing out that we still know very little about interconnections and functions of deep sea species. And
Mhm.
so the answer to the consequences of losing these species, we don't know for sure what the consequences will be. And I'll just give you one example. I've studied this group of giant protozoans that agglutinate sediments. They make a home out of sediments. They're about as big as your fist, and they're really
Okay.
fragile. They're very vulnerable to disturbance from humans. And we just 2 years ago discovered that they provide nursery habitat to the embryos of deep sea fishes. They
Oh.
found them deep buried inside. And I think, loss of biodiversity of these protozoans called xenophyophores, people might not have realized, that if you lose that species, you also lose
Mhm.
the nursery habitat for some snailfish.
Mhm.
And that's just one example, but I think most deep sea species, we don't really know exactly what they do and why they're important. But that doesn't mean they aren't important and that
Right.
there won't be consequences if we lose them.
Right. Very good point. So, from your experience, what would you say are maybe some practical challenges of researching deep oceans? Be interesting to hear.
Well, there are many challenges. I mean, it's very costly, and it's very remote. It takes a long time to get to in many cases, not always. Sometimes it's right outside your back door, but much of the deep sea is remote, and that contributes to the cost. It's vast, and so it's so large that we'll never know everything that lives in the deep sea. We'll never describe every species that lives there. And in general, it requires a relatively sophisticated technology. It
Mm.
requires a submarine or a remotely automated vehicle or autonomous underwater vehicle. And what this means is that we have to set priorities. It also means that the endeavor of deep sea research is basically a wealthy country endeavor
Mm.
that's practiced by perhaps maybe 12 or 15 countries, do most of the deep sea research in the world. So what we really need to do is find ways to engage and build capacity in the many countries that have deep sea. Most coastal countries actually have deep sea within their exclusive economic zones. And we also need to engage the landlocked countries that have no deep sea of their own, but they basically own the international waters, which
Mm.
is almost 2/3 of the ocean. So
Wow.
I think we have a long way to go in terms of building capacity and equity and inclusion in deep sea research, but the challenges are many. But I think that there are definitely ways we can make progress. The Decade for Ocean Research for Sustainable Development at the UN
Mhm.
is one good vehicle for this over the coming years.
Great. So, if you had to choose one, what would you say is the key message that you would like our listeners to take away from this interview?
I guess my key message is that the deep sea is half the planet.
Mm.
And it's the least known half, but that doesn't mean it's not important. When something is out of sight, it tends to be out of mind and people care less about it. So I think that our job as scientists is to engage the world in understanding the importance of the deep sea, its vulnerability. I really didn't talk too much about the fact that the life in the deep sea is very long-lived and much of it's used to stable conditions. So the changes that humans are imposing on the deep sea, both in terms of climate change and physical disturbance from resource extraction and waste disposal and contaminants, are likely to have big impacts. So on the other hand, it's also a place of wonder. I wish I could share some of the beautiful imagery on a podcast, but I can't. And I think I would encourage people who have an opportunity to tune in to the many telepresence streaming events that bring the deep sea right into your own computer and into your own home, because it's an awesome place.
Definitely, that's great. And would you say that you are optimistic or pessimistic about the future of our oceans?
I am optimistic. I think, and I want to be optimistic. I honestly think that we are talking about some of the most pristine systems on the planet now, and I would like to think that we can find ways to keep them pristine.
Great. Well, this has been very, very informative. Thank you so much, Lisa, for joining us. We greatly appreciate you taking the time to speak with us today.
You're welcome. My pleasure.
Our second guest was Professor Ray Hilborn, who joined us from his home in Seattle, where he teaches at the University of Washington's School of Aquatic and Fishery Sciences. He is the author of many OUP books, including Overfishing, What Everyone Needs to Know, and, most recently, Ocean Recovery, A Sustainable Future for Global Fisheries. In his books, Ray argues against the prevailing wisdom that overfishing is a core threat to our oceans.
Ray, thank you so much for taking the time to meet with us. We're very excited to have you on the podcast. Can you explain a little bit about your current work and how you got to that point?
Okay, yeah, certainly. I started out life as a terrestrial ecologist. I did my PhD on the cycles of small mammals like lemmings and voles, but then took my first job with the Canadian government's Department of Fisheries and Environment, and started working both on terrestrial and fisheries issues, and discovered that the fisheries issues were more interesting. And so I did that for 10 years after my PhD, and then I went and spent 2.5 years in the South Pacific working for an international organization that does science on the tuna of the Western Pacific. And then 34 years ago, I came to the University of Washington as a professor. And I've worked on a whole range of issues associated with the management of fisheries, what works, what doesn't work, what's the status of fisheries, and almost anything about fisheries management.
Ray, you are a more controversial figure among ocean health scientists. Can you tell us why and whether or not you think the label is justified?
Well, I think it probably is a bit justified in that I've been a skeptic of many elements of received wisdom that are widely accepted. And I think the reasons are twofold. One, that many, if not most of the people who contribute to the dialogue about fisheries don't really understand fisheries. They tend to be, a lot of them are marine ecologists who really have never worked in fisheries, whereas I've worked for before becoming an academic, I worked for fisheries agencies and worked in the nuts and bolts, at the coalface of fisheries. So I really understand them. And most of the people who do understand fisheries and see a lot of the errors and misconceptions work for agencies, and they're not free to speak out. really the only people who are free to speak out on these issues completely unconstrained are either academics or retired agency people. So there's a relatively small pool of academics who've ever worked in real fisheries. And the other is I very early in my career, I adopted sort of a skeptic's hat. And in those days, my big issue was hatcheries for salmon, which were largely viewed as the way to save salmon. I ended up being very skeptical about that, publishing a lot of papers on it, got to be very controversial, although I will say now that the vast majority of people who work in salmon pretty well agree with the things I was saying 30 and 40 years ago.
Great. Can you tell us a bit more about your recent book published with OUP, Ocean Recovery, A Sustainable Future for Global Fisheries?
Well, it's a book that is intended for the very general reader to really go through all of the issues associated with fisheries and fisheries management and fisheries impact on the ocean. You know, there's been a number of books that will highlight bad fisheries, but it, you know, I don't know of any book written for the general public that would really explain how fisheries are managed, or would really explain what I would say many of the key issues. You know, bycatch, what's the impact of bottom trawling? So it's really aimed to provide a base knowledge for the general reader on fisheries and its interaction with the oceans.
And one of the things that's really strikes me about your book is that it includes perspectives from scientists, managers, fishermen, and conservationists, like you mentioned, that are all involved in the industry. What new angles did these perspectives contribute to maybe your existing view of the future of sustainable fishing?
Well, I came to fishing from a very population dynamics perspective, and thinking about how you manage a fish population. A big change in my career occurred when a friend asked me if he said, "I'm a conservationist, should I stop eating fish?" And I know this happened. I know exactly when it happened. It happened in January of 2010, and I said, "Well, if you don't eat fish, what are you going to eat?" And he said, "Well, I'm not a vegetarian. I would eat more beef, chicken, and pork." And this really gave me a major career change in starting to think about fish as food rather than fish as a population to be managed, and then looking at how the relative environmental impacts of fish compared to other food sources. So then interaction with a whole bunch of other people in the food world, and so those who were just very different stakeholders than, you know, where I had come from, which was scientists in agencies and managers in agencies, and how many fish can we catch? It's, you know, where's this stuff go, and, you know, and what fisheries are relatively environmental friendly and which are not, and how do they stack up to other foods?
Going on that environmentally friendly point, you've said that fishing is one of the most environmentally friendly forms of food production. There was a recent impactful article published in Nature, which identified marine sediments as, quote, the largest pool of organic carbon on the planet, end quote. And it warns that the bottom trawling disturbs these carbon stores and risks adding to the buildup of atmospheric carbon dioxide. What would your response to that article be?
Well, that was a very long and complicated article, and at least 3 groups have already submitted critiques of it, because almost everything in that paper is wrong.
Okay.
And now I know a lot about bottom trawling, that I led a project for 10 years funded by American foundations looking at the impact of bottom trawling on the animals and plants that live on the bottom. So this wasn't directed towards the carbon issue, but one of the things we did is we got data to map the intensity of bottom trawling around the world. And so the first point is that very little of the ocean bottom is actually trawled. So most of the ocean bottom is deep, and no one is touching the bottom. Continental shelves, which are where the trawling takes place, only about 15% of the global continental shelves are touched by bottom trawling. So you say, yes, the bottom trawling are where the sediments are, but in fact, probably it's on the order of 1 or 2% of the bottom is actually trawled. There's a lot of chemistry in that paper, those calculations. It's outside my range. I know that the team of people who know about that stuff, who wrote a critique, suggests that they overestimated the impact from 10 to 100 times, and it's actually very interesting because that part of the paper wasn't even part of the paper when it was submitted, and somehow got tacked on at the end. Also, I just don't think that there's really much credibility in that claim. There may be an impact, okay, but it needs you need a team of people who are not agenda driven, and that paper was very agenda driven, to sit down and really figure out how big that impact is.
So you've mentioned that there is an agenda in this article from Nature. Why would you say that they are agenda driven?
Well, the lead author and many of the authors are well-known activists and advocates for marine protected areas. Okay, so this article, and there's an international movement that these people have been very prominent in, called 30 by 30, to close 30% of the land and the oceans, well, the oceans particularly, to fishing. And this article is just part of this 30 by 30 campaign to say, oh, look, there's all these benefits that could be had by closing 30% of the oceans.
So how would you distinguish between bottom trawling and other types of fishing in terms of their environmental impact?
Well, every form of fishing has an environmental impact. Every form of food production has an environmental impact. Bottom trawling tends to be among the higher carbon footprint fisheries, but certainly not always. There's lots of bottom fisheries that have remarkably low bottom carbon footprint, and that's mostly in the fuel used, because you're dragging nets through bottom. So
sure.
Trawling for shrimp tends to be a high carbon footprint form of fishing. So it really depends on how much you catch per hour, and so other fisheries can be very, very efficient with bottom trawling nets. Bottom trawling does impact the animals that live on the bottom, and there's all sorts of literature saying, oh, it destroys benthic ecosystems, and that can be true in very special circumstances, but almost all bottom trawling takes place on sediments that are pretty robust to the impact of bottom trawling. I think that, again, we've got a paper that estimates that, in some places that are really heavily impacted, the abundance of animals in the bottom might be half of what it would be in the absence of fishing. In the most extreme cases, it's maybe 90% reduced, but that's a trivial portion of areas. Again, globally, you might be seeing on continental shelves a 2 to 3% reduction in what's on the bottom. Now, compare that with agriculture. Okay, if you want to grow crops, what do? You either plow up a grassland and destroy a natural ecosystem, or you chop down a forest and you destroy a natural ecosystem. So compared to any form of agriculture, bottom trawling looks pretty good in terms of its impact on natural ecosystems. And the Marine Stewardship Council, which is sort of the best known certifying body, has certified quite a number of bottom trawl fisheries, and they meet what is principle 2 of the MSC standard, which is you will not alter the structure and the function of the ecosystem. Okay? No form of industrial agriculture meets that standard. Every form of crop production alters the structure and function of the ecosystem by clearing out all the vegetation.
That makes a lot of sense. Thank you very much. So Ray, what would you say are the major threats to the ocean?
Well, it's very clear, and I'd say agreed among almost everybody in the ocean community. The biggest threats to the ocean are climate change, particularly global warming, ocean acidification, sea level rise. There was a recent issue of National Geographic magazine that had this great graphic, and it compared different threats and different parts of the ocean. And if you look at the far right of the graph where fishing, they were all very low threat. And, you know, warming, sea level rise, pollution, land-based runoff, those were all the big threats. And I completely agree with that. And the idea that closing 30% of the oceans will save the oceans is nonsense, because closing 30% of the oceans to fishing doesn't affect any of those things.
That's a good point. The Netflix documentary Seaspiracy made quite a splash with its portrayal of the commercial fishing industry. Would you advise our listeners to watch it?
Well, it depends on how aggravated you want to get. I mean, it is, okay, first, it is not a documentary. It's a propaganda film with a very, with a very specific bias. And so, but obviously millions of naive people have viewed it and accepted everything it said. So I would advise that they first watch the mockumentary called Plantspiracy,
Okay.
Which is on YouTube, a 1 minute long doc that really just takes the Mickey out of Seaspiracy and shows that you could have made exactly the same film about crop production. That, you know, there is labor abuse, there's big environmental, everything that it says is terrible about fishing, you can also identify in growing crops.
Growing crops. What claims do you believe stray farthest from the truth that they mentioned in their documentary? I know you mentioned the labor production, but is there anything else that you would say really?
Well, at one level, they identify a whole bunch of standard issues in concern about fishing. There is overfishing in the world. There is illegal fishing. There is labor abuse. All of these things are true, okay? But they're also true of any other form of food production. and what they lie about is how extensive they are. So, you know, I mean, to me, the big message that they tried to put forward is, gosh, there's overfishing around the world and no one's doing anything about it. When in fact, for 40 years, thousands of people working for government agencies, working for NGOs, working for the fishing industry have been working to make fishing sustainable, to reduce its environmental impact, and enormous progress has been made. That in the half of the world that has good fisheries management systems, the abundance of fish stocks is increasing. The oceans aren't being emptied of fish, and that's the narrative. They say the oceans are being emptied of fish, and they paint this absurd picture that environmental NGOs like Oceana are part of this conspiracy to drain the ocean. You know, I mean, Oceana and I have lots of issues. I mean, but you know, I would never accuse them of conspiring to drain the oceans. And you know, and it uses very, you know, a few old quotes from thoroughly discredited papers that the oceans will be empty by 2048 and all the large fish of the ocean are gone. None of these are true, and they've all been thoroughly refuted. And they don't have any reputable scientists basically making those claims in the mockumentary.
Gotcha. So, Ray, what political agenda do you think that they are trying to propitiate in this documentary?
Well, it's very clear that the producer is a vegan activist. You know, he has this previous cowspiracy quote documentary, and that's really the message that is coming through. And I have to say that a vegan diet is a lower impact diet than the average American diet.
Right.
But you can have a lower environmental impact if you replace soy with fish. And there's a number of papers that have been out, and some have just come out, really showing that certain kinds of fish have very low environmental impact.
So, in the future, what do you think is the most environmentally friendly diet along that line?
You want to avoid livestock, no question about that, because it comes at a relatively high price. Unless if you can go out and shoot a deer off your front porch or without driving a giant pickup truck 500 miles. That's a very low impact form of production. But some kinds of fishing, particularly small pelagic fishes, have very low environmental impact. They're caught extremely efficiently. Salmon from Alaska tend to be very low environmental impact. But the real sleeper is shellfish, particularly farmed mussels, farmed oysters, farmed clams. These are probably the most environmentally friendly form of food production. They take very little energy, they soak up pollutants like nutrients, and they produce enormous volumes per unit area. So the Belgian diet, which I would say is mussels and French fries, is an incredibly low impact diet.
I'll take our lessons from the Belgians then. Thank you. What is the future of fisheries versus where do you think maybe the future of fisheries should be?
Well, fisheries is going in generally a positive direction. We have learned how to manage our target species very well. This is being done in roughly half of the world fisheries. The places that the less developed countries in general have not started to manage their fisheries particularly well, but the direction is good. They are recognizing that their fisheries are not being well managed, and they are starting to really try to do a better job of that. So where I would like to see fisheries go is for that to happen much faster and really bring good fisheries management to the parts of the world that don't have it. The other big part of fisheries concern is not management of the target species, but it is the environmental impact, whether you're talking the carbon footprint of the fuel use or more broadly the impact on non-target species. And again, we have made progress in that, not as much progress as we've made in managing target species, but we know what needs to be done. And it's just a question of making that happen much faster.
Great. Well, again, thank you so much, Ray, for your time. This has been very informative. Really appreciate it, hearing your insights.
Okay, it's been my pleasure.
We want to thank our guests Ray Hilborn, author of Ocean Recovery, and Lisa Levin, contributor to Natural Capital and Exploitation of the Deep Ocean. Please check out our show notes on the OUP blog for a free chapter from each of their books, along with a suggested reading list that provides even more context for understanding the state of our ocean's health and why it matters to us all. New episodes of the Oxford Comment will premiere on the last Tuesday of each month. Be sure to follow OUP Academic on Facebook, Twitter, SoundCloud, and YouTube to stay up to date on upcoming podcast episodes. While you're at it, please do subscribe to the Oxford Comment wherever you regularly listen to podcasts, including Apple Podcasts, Google Podcasts, Spotify, or Stitcher. Lastly, we want to thank the crew of the Oxford Comment for their assistance on today's episode. Episode 62 is produced by Stephen Philippi and Christina Fleischer. This is Julia Baker. Thank you for listening.